Hello friends, let's solve a problem on quantization. The problem statement is as follows. A binary channel with bit rate RB equal to 36,000 bits per second is available for PCM voice transmission. Find appropriate values of the sampling rate Fs, the number of quantization levels L, and the binary digits N, assuming the maximum signal frequency FM to be equal to 3.2 kilohertz. Let us try to understand the problem. What is given is the channel capacity that the channel can support 36,000 bits per second through it at this rate. So at what rate should we transmit our signal given that the maximum frequency of the signal is 3.2 kilohertz? So as per the sampling theorem, the sampling rate Fs must be greater than or equal to twice the maximum frequency of the signal, which is equal to 2 into 3.2 kilohertz, which is equal to 6.4 kilohertz or 6,400 hertz or samples per second. Now, with this Fs, how many bits per second we are transmitting through the channel? So Fs is the sampling rate, that is the number of samples per second. And now, given that one sample is represented by n bits, Fs samples will be represented by n times Fs bits. And because the sampling rate is Fs samples per second, the bit rate will be equal to n Fs bits per second. And that bit rate must be less than or equal to what is supported, what is the capacity of the channel, that is RB. This implies that n, the number of bits used to represent a sample, must be less than or equal to RB by Fs. Now RB is 36,000 and Fs is 6,400. This comes out to be 5.625. And now the number of bits must be an integer, and this n must be less than or equal to this number. So the largest integer less than 5.625 is 5. That is n equal to 5, or we can write it as the floor of 5.625, that is equal to 5 bits per sample. So we use 5 bits to represent one sample. Accordingly, the number of levels, quantization levels, therefore the quantization levels L, which is equal to 2 to the power n, and that is equal to 2 to the power 5, which is 32. So the number of quantization level required are 32. And now finally we need to compute the actual sampling rate. So the actual sampling rate, call it Fs actual, equal to, from this expression, Fs equal to Rb by n. So it is equal to Rb by n. Rb is, as you can note here, it is 36,000 bits per second. So it is 36,000 and n is 5, and that is 7,200 samples per second. This completes the problem. So if for the given signal of maximum frequency 3.2 kilohertz, we sample this signal at a rate of 7,200 samples per second, then it will satisfy the sampling theorem, as well as it will ensure that we transmit at the maximum bit rate, which is less than the channel capacity given in the problem. So I hope this problem is clear to you. Thank you.